Okay, so part two, just going to go through one more slightly different example, and this one about solving a titration equation. So for this one, we've got calculate the volume of 0.5 moles per decimeter cubed sodium hydroxide solution that would be needed to neutralise 20 centimeters cubed of sulfuric acid with a concentration of 0.4 moles per decimeter cubed, and they're giving you the balanced equation there. So again, just bear with me, I'm just going to try and put it so I can have my working board on the same space and so you can see both. Okay. Right, first step, as I said before, let's write down the chemicals. So we've got sodium hydroxide and we want our equation, concentration equals moles over volume, and we've got sulfuric acid H2SO4 with concentration equals moles over volume. Right, first step, what are they actually asking us to do in the question? So they want us to calculate the volume of sodium hydroxide. So that is what we're going to be working at this time, calculating the volume. Let's put in the numbers that we know. So we'll do our triangle. What do we know about sodium hydroxide? We know the concentration, so we know it's 0.5 moles per decimeter cubed. And that's all we know about it. So we don't know the moles and we don't know the volume. What do we know about the sulfuric acid? We know the volume's 20 centimeters cubed. So we've got 20, but it's in centimeters, so we need to divide it by 1,000 because it's centimeters cubed. We need to turn it into decimeters cubed. So that is 0.02. I'll just tidy that up. So 0.02 decimeters cubed. And we know the concentration of sulfuric acid is 0.4 moles per decimeter cubed. We don't know the moles. So that's all we know at the moment. Right, just making sure we can see it all. So that's all that we know at the moment. The whole question is wanting us to work out the moles, the volume of NaOH, but we can't do that until we know the moles. So what can we work out? Well, we know these two numbers, so we can work out the moles over here. So concentration times volume. So 0.4 times 0.02 equals 0.008. Obviously you put that through your calculator. So I'm just going to tidy it up so it makes more sense. 0.008 moles. So now we know how many moles of H2SO4 we've got. And we need to use that to work out that. So that's when we come to our equation up here. So for every 1 mole of H2SO4, because it's, remember, if there's nothing there, we draw it as a 1. So 1, worst 1 ever. Right, 1. So for every 1 mole of that, we need 2 moles of that, which means, so it's 1 H2SO4 to 2. I know I've written, don't get confused because it's 1 and 2 in here, I've written 2 and 1. It's because the 2 goes with the NaOH, 2 NaOH and 1 H2SO4. So what it's saying is, for every 1 mole of H2SO4, we need 2 moles of NaOH. So how do you turn a 1 into a 2? You double it, you times it by 2. So that means if we had 0.008 moles of this, we need to times it by 2, and we will have 0.016 moles of that. So we've filled in the first blank. Oh, I'll put a pen. 0.016. So now we know the moles. and we know the volume, so we can do 0.016 divided by, sorry, not the volume, the concentration, 0.016 divided by 0.5, and that gives us the volume. So 0.016 divided by 0.5, and that equals 0.032. So again, I'm just going to rub that out so I can tidy it up a little bit here. 0.032 decimeters cubed. And then weird triangle, right. But we tend to want to give the answer not in decimeters cubed when you're talking about volume. It gave the volume up here in 20 centimeters cubed, so we want to turn that into centimeters cubed. So you times it by 1,000. So that would be 32 centimeters cubed. 32 centimeters cubed. Let's just go back to our question and just check. So we know the ratio is 2 to 1. So we know we're going to need twice as many moles of this as that. But we know that the sodium hydroxide, that one was 0.5 moles per decimeter cubed. And this one was 0.4 moles per decimeter cubed. So if they were exactly the same, if they were both 0.5, you would need to use twice the volume. So we used 20 centimeters cubed of that. If they were both the same strength, you'd expect it to be 40 centimeters cubed, roughly. But they're not the same strength. This one is slightly stronger. This one is 0.5 compared to 0.4. It's slightly stronger. So we're expecting an answer that is roughly 40, but slightly less. And our answer, when we worked it out, was 32 centimeters cubed. So that fits our just checking that we're in the right area. Hopefully that helps.